Now we will talk about LCM, and LCM stands for lowest common multiple. So in case of LCF, we have talked about factor, that means the highest common factor, and in case of LCM, we will learn about multiple. That means here we have no dealing with factorizing or factors of any number. So for 4, 6 and 8, we will just write all the multiples of the three numbers. Okay. So 4 1 the 4, so 4 itself is a multiple of 4. Then 4 2 the 8, 4 3 the 12, 4 4 the 16. Then we will keep writing the multiples of 4. Okay. For 6, we will similarly write the multiples for 6. So I have written some multiples for both all the three numbers. So now we will just mark the common multiple of all the three numbers. So firstly we can see in case of 4, 6 and 8, the first multiple that we can see is 24, that is in all the three numbers. Okay. In case of 4 and 6, we have a 12 in both of them, but in case of 8, we have no multiple like 12, so we can't take that. So we have to consider all the three numbers. So in all three numbers, we have 24, the first multiple, and then we have okay. So let's just mark the extra multiple over the three numbers. So we have 28 here, but we don't have 28 here. Okay. So if we just continue, we will see we will have 44, 48. So 48 is also a multiple for 4. And then here. Okay. So we can see if we just continue the process of multiplying, we will see lots of multiple that are in common in between 4, 6 and 8. But in case of LCM, then LCM is the multiple which is the least common among all the three numbers. So in case of 4, 6 and 8, before 24, we will not get any multiple that are common in between these. So here our LCM is 24. That is the least common multiple. It's said least because it is the lowest possible common multiple in between among this number. Again, common multiple. So 24 is a multiple that is actually common in between all these three numbers. So our LCM is 24. That is the least common multiple is 24. 48 is also a common multiple for 4, 6, 8. But we can't turn that as LCM because that's not the least possible common multiple. So we have to take the least possible common multiple among some numbers. Okay. So here we will learn how to find LCM through two processes. First one is with the help of prime factors and then with the help of Euclid's method. So for the prime factor method, we have to determine the prime factor. That means we have to factorize each of the given number first. Then we have to find out the LCM. So let's just find the factorization form for all the numbers. we just factorize 12, we get, okay, similarly 18. Now we will write the factorizing form for each of the number. So our first work is to factorize each of the number. That means okay. So here now we will see which are the common number we get here. So firstly, we have maximum number of 2 2's over here. So here we also have 2 2. Here 1. So in case of LCM, in case of determining LCM, we will take all the numbers and we will take all the number in the that is present for the maximum time. That means here we have we have maximum 2 over here. So we will take 2 2. Then we have 3. So I can see here we have 2 3 maximum. So we will multiply 2 3's, and then we have 5. 1 5 max. So we will take 1 5, and we have 1 7. So in case of LCM, there is nothing like a fixed number that is to be in common in between the given numbers. Here we will take each of the factor. Also, we will take the maximum number of a factor. That means if there is like a given number, we have 10 2 in the factorized form of a number, we will take the 10 2 in determining LCM. Okay. So if we just multiply these, we will get 2 to the 4, 4 to the 12, 36, 35. So our LCM is 1260. It's our required answer. Okay, for in case of Euclid's method, so this prime factor method is not that much suitable. If it's mentioned in your question that find the LCM of some numbers with the help of prime factor, then you can use this process. But if you are not saying which process LCM is to be determined, like you are given a big word problem, and for solving the word problem you need to do the LCM. That means it's a part of your question. So for that case, it's more suitable to use the Euclid's method rather than this prime factor method. But if in the question it's mentioned that you have to determine LCM by prime factor method, then you need to do in this way. So in case of Euclid method, it's quite interesting. So here we have factorized, like here we have factorized 12 by using an L-shaped number. So in case of Euclid's method, we will do the same, but we will just factorize the numbers at a time. Like we will factorize all the numbers 12, 18, 20, 105 at a time. So firstly, we will put all the numbers 12, 18, 20, 105. So our first work is to put a L-shaped bracket like this. Okay. So similarly, we will start dividing the number with the help of simple or lowest possible prime number. So we have to keep in mind that the prime number that we are taking, the number given in the question is actually divisible by the prime number. That means at least 2 or 3 number of the total numbers are divisible by the given prime number. So here we can see 12, 18, 20. 3 of the numbers are divisible by 2. But 105 isn't divisible by 2. That's not an issue. So as 2 or more than 2 are divisible by 2, so we will take 2. So 2. So if we divide 12 by 2, we get 6. Then if we divide 80, then we get 9, then 10. As 105 isn't divisible by 2, we will keep 105 as it is. That means we will keep 105 like this. Okay. So again we will divide the numbers by such a number that can divide the number by at least 2 numbers. So we have taken 2, so now we will take 3, because here 6 is divisible by 3, 9 is also divisible by 3, 10 isn't divisible by 3, but 105 is divisible by 3. So we can take 3. Okay, so we have taken 3 here. So if we divide 6 by 3, we get 2. Since 10 isn't divisible by 3, we will keep 10 as it is. And if we just divide 105 by 3, we get 3 is 9 and 25. Now we will again divide by such a number which can divide up to 2 times. So up to 2 digits. So here if we can see, we can calculate with 2, because here 2 and 10 is divisible by 2. So we take 2. So here we get 1. 3 is divisible by 2. So we will keep 3 as it is. Then 5 to the 10. So 5. 2 is 35 is divisible by 2. So we will keep as it is. Here, if we again see here, we can see 5 and 35 is also divisible by 5. That means here we can divide again one time through 5, because here both 5 and 35 is divisible by 5, but 1 and 3 isn't divisible by 5. So we will keep 1 and 3 as it is. If we divide 5 by 5, we will get 1. And if we divide 35 by 5, we will get 7. Now if we are to multiply all the numbers in this sequence, so if we just multiply all the numbers, 2 into 3 into 2 into 5 into 3 into 1 into 7. So here we will see, we will also again get 1260. That means the same result that we get in the prime factor method. So you can follow both the prime factor method or Euclid's method, but in case of big word problems, it's easier and less time consuming to use Euclid's method.